Lee. I'm a math tutor at Wyzant. I'm answering a question that was submitted by a student. Like so many questions in math, I really think drawing a diagram is the best way to think about this stuff. And once you get really comfortable with this, this is called a piecewise function. Maybe a diagram isn't that necessary anymore. But let me just rewrite the equations here in piecewise form. There's this function h of x, and what we usually do is we have like a bracket like that. H of x is equal to 3x plus 2 when, that's a comma there, when x is greater than or equal to 0. And h of x is 5x minus 1 when x, so I missed that, equal then. Here we go. And then this is when x is less than 0. And as I indicated, I think the best thing here is to consider a quick sketch. And this top piece, when x is greater than or equal to 0. So this is going to be a filled dot because of the equal sign here. And it's going to be this height is going to be 2, and it's going to have a slope of 3. So it's going to look something like that. And when x is less than 0, the function is going to have an y-intercept of -1. And it's going to have an open dot because of the strictly less than 0. And it's going to have a very steep slope like this, maybe going down like that. I'm trying to make that look like a steeper slope. It doesn't look a whole lot steeper, but I'm not an artist, but that's reasonable. Okay, so now all we want to know is what happens when x here is, obviously this is x here and this is h of x here. What happens when x is -6? So visually, we can think, oh, we're over here. Here, that's 6, -6 here. Well, then it's down here somewhere. It's going to be a fairly small number, quite negative down here in the third quadrant. So I just think a diagram helps. Yes, you can just do this algebraically. I think it also helps to write the function using this bracket notation, because this just tells you when you're -6, where are you? Are you in the upper half of this thing, or are you in the bottom half of this thing? And you're in the bottom half. So to get the exact value, we're just going to plug -6 into the bottom half. There's -6 is less than 0, and so we're going to have 5 times -6 minus 1. So that's going to give you -31. So it's way the heck down there. -6, -31. Which is pretty much what you expect from the quick sketch that you did. So it's a nice, easy problem. Get used to the idea of working with piecewise functions. Piecewise functions come up over and over in math. And the reason is that they're interesting. They have certain properties and certain behaviors that make things interesting. But also, piecewise functions come up in the real world all the time. So, for example, if let's say you're buying supplies, building supplies, and you're paying so much for 100 bricks or something, and they might charge you a certain amount, maybe $3, maybe five. Let's say $3 a brick if you're buying a small quantity of bricks, and $5 a brick if you're buying a. I'm sorry, $5 a brick if you're buying a small quantity of bricks, and $3 a brick if you're buying a very large quantity of bricks. That would be a real life example of a piecewise function. So piecewise functions occur in the real world. But they're also very interesting mathematically. So get used to the piecewise function, and I strongly encourage you to do a quick sketch when you see these problems. Okay, that's it for this one. I'll see you again next time. Bye bye.